So hi, everyone. I'm Stacy Knapp, and I'm here to update you on our current progress toward meeting our greenhouse gas reduction goals. So starting with the end in mind, I'll first show you the time series of our gross greenhouse gas emissions, then I'll start breaking it down. So first, let me call your attention to the dark blue line in this figure. This represents the gross greenhouse gas emissions in Maine from 1990 through the most recently available data year, which is 2017. You can see years along the x-axis at the bottom, and the level in terms of million metric tons of carbon dioxide equivalents along the y-axis to the left. As you can see, we start off at 21.2 in 1990. Levels increased to the high of 26.5 in 2002, and since 2002, greenhouse gases have been declining, primarily due to the decreased use of fossil fuels. By 2008, emissions were below 1990 levels, reaching a low in 2012, rebounding slightly 2013 to 2015, and then trending downward again in 2016 and 2017. The total reduction in annual greenhouse gas emissions between 1990 and 2017 is 17.5%. The reduction between the peak in 2002 and 2017 is 34%. Now, if you take a look at the dotted line in this figure, you'll see our most recent levels are below this line. That dotted line represents the 2020 goal, which is to be 10% below 1990 levels. That number is 19.1. So at 17.5, we're already meeting that goal. Of course, we need to wait a few more years for the 2020 data to be available to know for sure. So here you can see that same time series along with where we need to be in future years. So we need to be 10% less than 1990 levels by January 1st, 2020, 45% of 1990 levels by January 2030, and 80% of 1990 levels by January 1st, 2050. And of course, we also have an additional goal to achieve carbon neutrality by 2045. So let me break down how we analyze this data. For gross emissions estimates, we primarily use EPA's state inventory tool, or the SIT. The SIT is an Excel-based computer model developed by EPA, which can be updated with data from state programs to estimate greenhouse gas emissions in Maine. The SIT was developed by EPA to provide states with a comprehensive and standardized approach to estimating greenhouse gas emissions. So all of the states use this method, so the methods are consistent and comparable and additive. This tool considers the same sources that are used in the National Greenhouse Gas Inventory, which is developed by EPA, and is based on the recommendations of the Intergovernmental Panel on Climate Change. So now, since activity data are the basis for emissions estimates, the SIT does contain default activity data to make the tool as useful as possible. Where there isn't data available, modeling results are used. However, as I mentioned before, states can update this data. It's very user-friendly. The SIT provides flexibility for states to input state-specific data where that data is better. Now, that said, the default data are based on national databases, primarily the Energy Information Administration's State Energy Data System, or SEDS. And much of that data in these national databases are compilations of state-submitted data. So in a sense, we're sending data up to these national databases, and then EPA is feeding that data back down to us through the SIT. So we do, in fact, change pieces of the default data, though. We enter some data that is reported directly from facilities. About 140 facilities in the state of Maine are required to report emissions annually. We also pull some data from other state departments and programs. For example, we enter the amount of methane flared at landfills, methane captured from landfill gas to energy projects, state vehicle miles traveled, industrial process-specific data, and solid waste data. So with all of this data entered, the SIT has a synthesis tool that pulls all of the modules of that model together and provides gross emission results. This is including all greenhouse gases in terms of source categories. Source categories include industrial processes, agriculture, waste, and energy. And these results are given in million metric tons of carbon dioxide equivalents. So that includes all greenhouse gases, such as carbon dioxide, methane, N2O, HFCs, PFCs, and SF6. The SIT also breaks down the results of just CO2 from burning fossil fuels into sectors. So CO2 from burning fossil fuels accounts for 90% of the gross greenhouse gas emissions. So it's a very informative breakdown. These sector categories include residential, commercial, industrial, transportation, and electric utilities. And these results are given in million metric tons of carbon dioxide, which is CO2 only. Now, emissions from renewable energy sources are not included in the most recent report. However, the energy consumed is included in Appendix D for those that are interested. Now, these energy sources include fuel ethanol, wood, and waste products, including black liquor and sludge, hydroelectric, wind, solar, and geothermal. Now, emissions from those sources that produce greenhouse gases will be included in the next report. Non-combustible renewable energy sources such as hydropower, wind, and solar do not produce GHG emissions directly. So for the current report, emissions from combustible renewable energy sources in Maine, such as biomass and biofuel, have been treated as offset by the carbon absorbed during the biomass growth, but that will be different in the next report. Okay, so let's jump back into the data. So here you can see the gross emissions broken down by source category. This is for the most recently available data year, which is 2017. So it's pretty obvious who the winner is here, right? That giant blue segment is 90% of the pie. The demand for and consumption of energy drive the clear majority of Maine's greenhouse gas emissions. Agricultural activity, industrial processes, and waste disposal combined only contribute 10% of the 2017 greenhouse gas emissions total. We can break this energy consumption down by energy source. You can see a time series here from 1990 to 2017 that shows the energy consumption by energy source in terms of BBTU. A few highlights here. In 2017, total energy consumption in Maine was 14% less than in 1990, which is great. In 2017, petroleum products accounted for 49% of all energy consumed and for 84% of the CO2 emissions. The reduction of residual fuel oil consumption, which has been 95% since 1990, is a large driver of the overall decline in these greenhouse gas emissions and consumption. So although Maine still relies on petroleum to meet some energy demands, CO2 emissions continue to decline in part because of the lower carbon fuels, increased efficiencies, and increased renewable resources. So let's take a closer look at that blue segment at the bottom, petroleum consumption. And here you can see that broken out by fuel type. So overall, there's been a 26% decrease in CO2 emissions from combustion of petroleum-based fuels since 1990, and a 23% decrease in consumption since 1990. So this may be explained in part by the increase in natural gas use. Since 1990, there has actually been an 887% increase in natural gas consumption. So that's a big piece. Here you can see that time series broken down by sector. Again, there's a winner here. Transportation sector has been the leading consumer of petroleum for all years, from 1990 to 2017, with a 6% increase in petroleum consumption during that period. All of the other sectors have reduced consumption of petroleum since 1990. Looking at emissions, the same trend holds true for 2017. So this is the figure that Cassie shared with you earlier. And as you can see here, the transportation sector produced over half of all CO2 emissions in Maine in 2017 from the combustion of fossil fuels. The residential sector accounted for the next highest amount of emissions at 19%. So here you can see that emissions data as a time series from 1990 to 2016. Actually, it should be 2017. The transportation sector emitted 54% of the state's total CO2 emissions in 2017, as we saw in the last figure. The transportation sector has been the leading contributor of CO2 emissions for all years, with a 2.5% increase in CO2 emissions during that period. The industrial, electric utility, and commercial sectors reduced emissions by 58%, 50%, and 24% respectively between 1990 and 2017. So starting to wrap up here are the key findings of the most recent analysis. So gross emissions in 2017 were 17.5% below 1990 levels. You saw that in that first figure. 90% of those emissions are the result of energy consumption, mostly from combustion of petroleum products. You saw that in that first pie chart. 54% of Maine CO2 emissions in 2017 were from the transportation sector. CO2 emissions from fossil fuel combustion in the electric power sector have decreased by 83% since they peaked in 2002, so that's definitely something to celebrate. And the transportation and residential sectors have both the highest consumption of petroleum and the highest emissions of CO2 from burning fossil fuels. So the next greenhouse gas report is due to the legislature at the end of this year, so actually December 31st of this year. And that report will be a bit different than previous reports in that we'll be including a number of additional data sets. We'll be including biogenic emissions in this next report, which are emissions from the combustion of renewable sources of energy, such as wood and ethanol. For an easier comparison to previous reports, we'll be reporting both gross emissions in both ways. So we'll be reporting it together with renewable resources as well as without, so people can compare to previous greenhouse gas reports. In addition, we'll be reporting on emissions from electricity consumption, that is emissions from electricity consumed in the state, whether or not it was produced in Maine. Historically, we've only counted emissions from electricity produced in the state. Now, this will be a standalone section included for full transparency and because it's informative for some policies and strategies. The standard methodology, though, will be included in the overall gross emissions for accurate comparison to other states, so apples to apples. We will also be reporting on carbon credits in Maine. And perhaps the biggest addition, we are now required by statute to report net greenhouse gas emissions. So we'll be including details of the University of Maine carbon budget in the next analysis to track our progress toward carbon neutrality. Here is a snapshot of the most recent University of Maine carbon budget. As you can see, there are a lot of sources and things to consider. I'm not going to get into this in any detail, but just to show you the number of buckets that researchers have considered here. So these data are based on a 2006 to 2016 window, and we're starting to talk about ways in which we might be able to update these data going forward for future reports. So the full report is available on the DEP website, the previous report, for anyone who's interested and doesn't have a copy. As I mentioned, the next report is due to the legislature on December 31st of this year, and that will also be made publicly available on the DEP website. With that, I'll hand it back to Cassie and